Hi.
How you doing tonight? Or I should say this afternoon. It's not quite dark yet.
Good.
Good. So what are we doing tonight? I didn't notice any emails from you.
So I just sent the URL for the website to in the chat thing
Oh,
for
okay.
this. So
Have a look at it. Yeah, I see it. Okay. I want to go to Common Core High School, right?
yes.
And I want to go to Algebra 2.
Yep.
Whoops, I looked like I went backwards. Yeah, I think I did somehow. I'm not sure what. Let's try it again.
Yeah, I don't know why it does that. So my teacher gave me the individual problems, so I can tell you which ones we need to do.
Okay. First of all, where do I go from here?
So the page is page 61.
All right. Okay. Which problems?
So the first one, or first set, is 22 to 30 and even. So it's 22, 24, 26, and 28
Okay.
and 30. So all the even ones from 22 to 30, pretty much.
All right. Is there a way to close off this left portion here? I noticed that it doesn't look like it.
I don't think so.
All right. It's all right. As long as you can read this,
Yeah, I get it.
we're fine. Okay, so they want the vertex, the axis of symmetry, and they want you to label it. Well, what's the first thing we need in order to graph it? What's the most important point of a quadratic?
Um,
Quadratics look like this. They either look like this or they look like that. What would be the most important point of both of those?
the vertex.
Yeah, that point
Okay.
right there. There's no other point on that graph that is as interesting as that point. So that's where we should start. When we're gonna graph it, we've got to find the vertex. Plus, it says label the vertex, so we know we have to find the vertex. Well, how do I find the vertex of a quadratic that is in standard format?
Um, so
There's a couple of ways. To me, the easiest way is this one.
yes, yeah.
That is the x-coordinate of the vertex only. So what does that equal to in our case? In other words, with number 22.
So that's 6 over 2 times 3, so 6.
So that's the x-coordinate of the vertex. So if I go to 1, I know that the line of symmetry goes through that x-coordinate. In other words, my vertex is somewhere on that dotted line. Now, how do I find the y-coordinate of the vertex?
I don't know.
Plug in the x-coordinate into the equation. That's all you do.
Okay.
So what's the y-coordinate going to be?
So
Remember, the x-coordinate is 1. So plug 1 into the equation.
so y equals 3 times 1, so 3, so 9. So 3 squared is 9.
No, it's not 3 squared. It's 3 times 1 squared. That's 3. Here.
Oh, right.
Write it.
Yeah.
It's 3 times 1 squared minus 6 times 1 plus 4. And it never hurts to do this step. In fact, I would recommend it every single time, because it prevents you from making mistakes. When you try to do that whole thing at once like you did, you made a mistake. You squared 3 instead of squaring 1 and multiplying it by 3. Well, that makes a big difference. That's 3 instead of 9, minus 6 plus 4. What's that equal to?
1.
Okay. So now we know the y-coordinate of the vertex also. In other words, there's the vertex, 1, 1. Now, based on the original equation, is that a parabola that opens up or down?
It's one that opens up.
Yeah. In other words, something that looks like that. And the only reason you know it opens up is because that is a positive number. If that was a negative number, it would open down. Now, it's always useful to have more than one point, because a parabola could be, in other words, I could have a vertex there, but it could be looking like that. It could also be looking like this. So the width of the parabola is important. So notice that if I can solve for one other point on the parabola, 3 points is all it takes to define a parabola. 3 points.
Right.
So how about the y-intercept? That'll give me a second point, and then you'll be amazed at how easy it is to get a third point. What's the y-intercept?
1. Or, hold on.
The y-intercept is always that constant. Plus,
oh, yeah, 4. Okay.
Okay, in other words, the definition of y-intercept is when x is equal to 0, right?
Yeah.
And the definition of x-intercept is when y is equal to 0. Always remember those two facts. They're very critical. So if I'm solving for the y-intercept, I set x equals 0, I get plus 4. So that thing is 0, 4, that point right there. I know the vertex, so now that I have 2 points, but I also know that it is symmetrical about that axis of symmetry, which is at 1. So what is this point over here?
2, 4.
Yeah, exactly. In other words, you go the equal, this first point was 1 unit away from the line of symmetry. You want to go 1 unit on the other side of it, which is 2, same y value. And now we have 3 points, and that's all you need to label or graph a parabola. You actually need a little bit more than what they're asking for. They said label the vertex and axis of symmetry. Well, that doesn't tell you how skinny or fat the parabola is. So if you really want to graph the function, which it says to do, you've got to come up with another point other than the vertex. So it definitely requires you to come up with 3 points. And usually the easiest second point is the Y-intercept because it's so easy to get. And then you find the point opposite it on the other side of the axis of symmetry, and you have your 3 points. And then you can draw the graph. You can't really draw the graph unless you have 3 points. You can't just draw it based on the vertex.
Okay.
24.
Yes.
Again, what is the x-coordinate of the vertex, the general? Minus what?
Minus our opposite b over 2 times a. 2a.
So now, given that this is our function, tell me what minus b is.
6 again.
What's 2a?
-2.
So the x-coordinate of the vertex is at -3. That's the x-coordinate of the vertex. Also happens to be your line of symmetry. So if I wanted to, I could go ahead and draw that line of symmetry in at -3. The only thing I don't know yet is where the y-coordinate is. How do I get the y-coordinate of the vertex?
Plug the x into
the x-coordinate into the function. That gives you f of x. So tell me what I should write.
So
it's a little tricky. You got to write this very carefully. I'm substituting -3 wherever I see x.
Right. So it's 3 squared.
No, nothing happened to that minus sign. Well, let's write it like this. I want to make sure you know exactly how to do this.
Then.
Okay. What's the rest?
6 times -3. And then +3.
Okay. Now the reason I write it like this is because I'm looking at 1, 2, 3, 4 negative signs. Negative signs throw people off. They just do. Always. Okay? So when you have a lot of negative signs, you want to write it out this way and then simplify it. If you try to do it in your head, you're going to make a mistake. Guaranteed. Now, what's the next row?
So that's negative. Wait, so -3 squared is 9. So -9.
Good.
And then is 18 plus 18 plus 3.
That was a +3. Okay. What's that whole answer?
So 12.
Okay. So my vertex is at -3, 12. So it's way down here. That's -3, 12. In other words, once we, excuse me, sorry, it's way up here. -3, 12. Let me erase this one down here. Apologize for that mistake. But notice that the vertex is always on the line of symmetry. It's just a question of where it is. I'm going to erase some of this other stuff so I have room to write. We've found our vertex. That's the most important point to find. Okay? It's not the only point we have to find, but it's the most important point. 3, 12. That's right there. Now, tell me whether this opens up or down.
Down.
So it's a parabola like this.
Right.
Now, we have to find two other points. And there's actually two choices. We can solve for the X Intercepts, which means setting f of x equal to 0 and solving that quadratic, which is difficult. The easy thing to do, what's an easier way to get a second point?
The
Y-intercept.
Oh, yeah, the Y, yeah.
What's this Y-intercept right there? What is that point right there?
3, 0, or 0, 3.
And now we know because it's symmetrical, we know that point right there. What is that point over there?
6 or 0, or yeah, 6, 0.
Does it look like 6?
Oh, negative 6?
Negative 6. Right? I'm on the left side of the y-axis. That has to be a negative number. You see why it's negative 6? That distance is 3 units, right? So that distance has to be 3 units. Well,
Right.
This distance is 3 units to the left of the y-axis. So this distance has to be 6 units to the left of the y-axis, which means an x-coordinate of -6. The y-coordinate is the same because I'm not moving up and down, I'm merely moving left or right. So I've done all three things they wanted. I've graphed it, I've labeled the vertex, and the axis of symmetry. Now to actually graph it, you do need 3 points. You can't graph it with just the vertex. It's this would be a better question if they said graph the function and label 3 points. Because you have to have 3 points to graph it. All parabolas need 3 points. Can't graph a parabola with just 2. Hold on a second. What time do we start, Beatrice?
About 4.
Okay. All right, so let's look at 26. Now, notice the difference between 26 and 22 and 24. It doesn't have an x term. It only has an x squared term.
Right.
So, tell me what the x-coordinate of the vertex is.
So,
B.
0 over, so it's 0?
Doesn't matter what the denominator is. If the numerator is 0, our answer is 0.
Right.
Now, plug in 0. In other words, our axis of symmetry is the line x equals 0. Now, what's y equal to when x equals 0? In other words, what is f of 0 equal to?
So,
Plug in 0 for x. What do you get?
-5.
That's where it's at. Does this open up or down?
Up.
Okay, so it's some kind of a parabola that looks like that. We know the vertex, 0, -5, and we know the axis of symmetry, but we didn't really graph it accurately because I didn't figure out what points those two were. Now, notice on this one that doing the Y-intercept doesn't help. I got the Y-intercept when I got the vertex. If I don't know the X-intercepts, I can't graph it properly. So how do I figure out the X-intercepts? Because I really have to do that. It says graph the function. It wants more than just the vertex and the axis of symmetry. I've given it the vertex and the axis of symmetry, but in order to graph it, I need 2 other points. Right now I only have 1 point, the vertex. So I got to get, and in this particular parabola, I can't get a y-intercept. I already have a y-intercept. So I can't use that to get the other 2 points.
Okay.
So how do I get these x-intercepts? You want to know how to do that anyway.
So
What is y when when we are on an x-intercept, what is the y value?
0.
So therefore, I set f of x equal to 0. That's what y is. And I solve this equation. Now, solve that equation for me.
So add 5, so 5 equals 6x squared, and then divide by 6. So it's 5/6. And then square root it.
The answer?
That's fine.
Notice there's 2 solutions. What's the answer?
So positive or negative square root of 5/6.
Exactly. That's positive. In other words, the coordinates on that point are square root of 5/6, 0, because the y value is always 0. And the coordinates on that point are negative square root of 5/6, 0. So in terms of graphing it, I need these 2 points. Otherwise, I don't know where to cross the x-axis. So when they say graph a parabola, you need 3 points. Now, if the vertex is not on the y-axis like this one is, there's an easier way to get the other 2 points, and that's to get the y-intercept. But if the vertex is on the y-axis, then you can't use that method. You have to solve the equation and figure out where the x-intercepts are also.
Okay.
Let's see. 22, 24, 26. What's the next one?
28.
Okay. Well, that's just a standard parabola, standard quadratic, so let's use the same method. This is a nice formula here because this not only gives you the x coordinate of the vertex, but it gives you the line of symmetry.
Okay.
What is it for 28?
So the opposite be, so -1 over 1, I think. Yeah.
So that's the x coordinate of the vertex. And now what's the y-coordinate of the vertex? Let's do it this way this time. In other words, we actually could use the easier method, but let's figure out, no, we can't. We still have to figure out the y-coordinate, always. In other words,
Okay.
they want the vertex, so they need the x-coordinate and the y-coordinate. What's the
Right.
y?
So y equals.
And let's just plug it in. Don't try to give me an answer in one step. Let's plug it in and simplify it.
Okay. So 0.5 times 1 squared plus. Wait. Oh, it's -1. Sorry. So -1 rather than +1. Then
Okay.
-3.
All right. Now simplify this one step at a time.
So
It's -1 squared.
1. And then
-1 -3. What's this answer?
So 0.5 minus 1. So -1.5 minus 3. So -4.5.
That's -4 plus a half. -3 and a half,
3.5.
which is -7/2. Okay. So this is the y-coordinate. We got the x-coordinate. We can graph it almost, not quite. In other words, we really only still have 1 point. -1 -7/2. We're going to call that -1 -7/2. Did it open up or down?
Up.
What's the next easiest point to find on this parabola? Is it the y-intercepts or the x-intercepts?
The X Intercepts.
The y-intercept's always a piece of cake. It's whatever that number is.
Right. Oh, okay.
Y-intercept,
So it's
-3. So that coordinate is 0, -3, and that lets us draw our parabola. Because we know we are symmetrical about that, right? So
Right.
this point over here,
So that is
here's our line of symmetry. That's why they want that.
so -2.
It's the y-coordinate. Y-coordinate doesn't change.
-7. Oh,
Notice
okay.
that it's the
Right.
same place horizontally, right? Or vertically, rather. So the y-coordinate is
Right.
the same, -3. The only coordinate that changes is the x-coordinate.
Okay.
And now that answers the question totally. In other words, we've labeled the vertex, we've graphed it accurately with 3 points, and we've labeled the axis of symmetry.
Okay.
What's next?
Number 30.
Okay. Now let's just do these all the same way. As long as they're going to give us each function in standard format, then this is always the best way to start. Now, if they give this to us in vertex format, well, then you're staring at the vertex, and you don't need to go through this vertex of x. In other words, if they gave us an equation like this, where's the vertex?
1, 2.
Okay.
1,2.
So I wouldn't have to go through all this calculations. So it really depends on the format they give it to you. Well, for 30, that's standard format. When you start with standard format, this is the easiest way to go. What's the general formula for the vertex? The x-coordinate of the vertex?
So,
I always have students start with the general every single time.
okay. So, 4 or negative b over 2a.
Negative b over 2a, that's the general. Now fill it in.
Okay, so 4 over, I don't know.
It's 2 times minus 5 halves.
So 5?
Minus
Because
5.
10 over 2. So yeah, minus 5.
No, don't do it that way. Don't multiply numerators and denominators. It's the hard way. Always simplify first. Well, these 2's cancel out.
Oh, right. Yeah.
Always do it this way. Always. I notice a lot of students, they insist upon multiplying numerators, multiplying denominators. They put a 1 under that, and they get minus 10 over 2, and then they got a lot more math to do. Okay? But you don't have to do all that additional math if you simplify first. And in fact, I never dealt with a number greater than 5. Whereas if I do it your way, I immediately have a minus 10 to deal with. So always simplify. Makes multiplication problems so much easier if you simplify first. So what was it? It was minus 5?
Yes.
So the x-coordinate is minus 4/5. Realize that it doesn't matter if that negative sign is in the denominator, the numerator, or out front. It means the same thing, all 3 cases. Now, in order to graph this thing, we need the vertex. So we need the x and the y coordinate of the vertex. So tell me what I should write to get the y coordinate of the vertex. Do it step by step. And here is where you really want to do it step by step. Because this is complicated, it's really easy to make a mistake.
Okay, so it is y equals times the negative 4/5
squared
minus 4 times negative 4/5 minus 1.
Notice again why it's so easy to make a mistake here. I got a negative sign there, there, and there. I got so many negative signs, people hate it. There's nothing that people hate worse than negative signs. Trust me. So that's why the reason I tell everybody to do this one step at a time. Now, simplify it, and the first thing you want to do is the exponent. So let's just leave that 5 halves there. Now what is that squared?
I don't know.
Square the numerator, square the denominator.
Okay, so 16 over 25.
Yeah. And it is a negative number squared, which we know is going to turn positive. So that's correct. Okay, now what goes here?
Uh, 8 over 5, because the 4 and 5 don't.
You're multiplying, not subtracting.
Oh, right. So it's 16 over 5.
Okay. And it's a plus because I have a negative sign there and a negative sign there, which I'm multiplying together gives me a plus.
Right. Okay.
Now, let's simplify. That 5 goes into that 25 5 times, leaving a 1 there and a 5 down there. And so what do I have?
Okay.
I have minus 16 over 10. That's what that is, right? Plus 16 over 5 minus 1. How do I solve that?
So
How do I add two fractions that have a different common or a different denominator?
you need to make a common denominator.
Okay, what's it going to be here?
So 15?
10.
Or wait, hold on.
10.
Yeah, 10.
The definition of a least common denominator is the smallest number that both of these numbers will divide into. Well, 10 divides into 10 evenly, and 5 divides into 10 evenly. So the least common denominator is 10. Turns this 16 over 5 into what? If I want to give it a denominator of 10. What's the equivalent of 16 over 5, only in tenths?
So 32, I think, over 10.
Yep. Minus 1. Now I can operate on just the numerators. So that becomes 16 over 10, what I have circled there. Minus 1 becomes 6 over 10, becomes 3 over 5. That is the y-coordinate of the vertex.
Okay.
So my vertex, if I graph it, is at minus 4/5. That's the x-coordinate. And positive 3/5. That's the y-coordinate. So it's minus 4/5, positive 3/5. Would it open up or down?
Down.
Yeah, so it opens like this. Now, I haven't really graphed it. I've graphed an approximation of it because I've only used one point. So I either need these x-coordinates, or the easier thing is that y-coordinate. What's the y-coordinate?
1.
Minus 1.
Yeah, minus 1, sorry.
So that's 0, comma, minus 1, which makes this third point what? Got to go an equivalent distance that's that distance to the left.
So 2 comma negative 1?
Well, 8, how about minus 8/5? See why that's the x-coordinate?
Yes, because you
That's
need
the
it.
same distance from the y-axis. It's 4/5. And the y-coordinate doesn't change, so there's my third point. So I have 1 point, 2 points, 3 points, which allows me to graph it. I also know the vertex and the axis of symmetry, which is x equal minus 4/5. All right, what do we have next?
So, let's see. It is problem 33.
33, okay. What's wrong with this solution in 33?
The general equation is the b is normal, so it has to be opposite or negative b.
Negative b. It's not b over 2a, it's negative b over 2a. Okay, what's next?
Oh, that was easy.
Yeah, really. I mean, when they give you an obvious mistake like that in the general, that definitely is easy.
Yeah. So 36.
Okay. Now, it turns out that in the real world, all projectile motion follows quadratics.
Right.
They're all can be represented by a quadratic. Notice that that is a parabola. And there's the vertex right there, and so forth and so on. So this is wonderful. That means that projectile motion is always a quadratic equation. Let me see
Okay.
what they want here. The instructions are. Find and interpret the coordinates of the vertex. All right. Well, they give us the equation. Let's find the vertex. Again, it's in standard format. So we always want to use the general formula.
Right.
Which is?
So that is 0.7 or negative 0.7, 0.7 over negative 0.012, I think. Yeah.
It's that simplified too. You can do it in a calculator if you need to.
Okay. Huh? I got 35. I think I did it wrong.
No, it's correct. In other words, 0.7 divided by 0.2 would be 3.5. 0.7 divided by 0.02 is going to be 35. And the minus signs turn into a plus sign. So that is the coordinate of the... Now, their question is, well, we need the y coordinate also.
Yeah.
In other words, we got to do the math. So let's, over here on the lower left, let's plug everything in. What do we got?
So y equals negative 0.01 times 35 squared plus 0.7 times 35 plus 6.
You have a calculator in front of you?
Yes.
Well, this is definitely a calculator problem.
Okay.
In other words, nobody expects you to be able to square 35 manually. So first do the exponential, square that.
Right. So that is 1,225.
Okay. Multiplying it by 0.01 moves the decimal places 2 points and makes it negative. So that's what the first part is. Plus what? What's 0.7 times 35?
24.5.
And finally, adding 6. Let's see, what do we have here? We have 12.25 plus 6. must be 18.25.
Yep.
That is the y-coordinate of the vertex. So now I can graph it. In other words, once you have the x and the y-coordinate, the x-coordinate was 35. Let me graph it. 35, 18.25. Well, that means the coordinates of that point right there are 35, 18.25, and that means that's 35, and that is 18.25. Now, what does it say? It says, find and interpret the coordinates of the vertex. Okay, well, we found the vertex. What does it mean? What have I said to you? What x value is that shot put the highest point possible?
At wait, what x value? So at 35.
Okay, and what is that highest point?
18.25 feet.
There you go. In other words, this is one of the reasons they spend so much time teaching you how to find vertex, is that in real life, when you throw anything, it doesn't have to be a shot put, it can be a tennis ball, a baseball, a football. When you throw something, it follows a parabolic path. Always. So if you want to know the maximum height, it's the y-coordinate of the vertex. If you want to know where that comes, it's the x-coordinate of the vertex. This 35 degrees was kind of unimportant. We really didn't need that. In other words, they didn't ask about that. They said, find and interpret the coordinates of the vertex. Well, we found the coordinates, and interpreting it means that's the peak. That's the highest point that that shot put hits, and we want to know what that point is and where it comes on the x-axis.
Cool.
What else do we have here?
So let's see. 42.
42. Again, it's a quadratic. They want to find the minimum or maximum value of the function. If I have a quadratic that looks like that, is it going to have a minimum or a maximum?
Minimum.
If I have a quadratic that looks like that, is it going to have a minimum or a maximum?
Maximum.
So that's all we have to do to figure out whether it's a minimum or a maximum, is check the sign. That's a negative sign. It means it's going to open down. So the first answer is maximum for 42.
Okay.
Okay. So we know it's a maximum. Describe the domain and range and where the function is increasing and decreasing. Well, unfortunately, we have to graph it here. We have to find the vertex, even though they didn't request it. You can't answer this question without the vertex. And that's why the vertex is the most important point on all parabolas. Because you can't really answer very many questions without finding the vertex. Okay, so same thing that we've done on every single problem. What's the x-coordinate of the vertex for 42?
Negative b over 2a.
Okay, what's that?
Wait, what are we on? 42. So 6 over -6, so -1.
Okay, what's the y-coordinate? We need that also.
So
Actually, we don't. Yes, we do. Sorry. Go ahead.
So -3 times -1 squared.
Again, write it out like this because there's so many negative signs. Is that a -5 or a +5? I covered it up.
I think it was a +5.
Yes. Simplify.
So -3 +6 +5
Equals
so
what?
8.
That's the x coordinate. Excuse me, that's the y coordinate of the vertex. Okay.
Okay.
Now we know how to graph it. We go to -1 +8. We know it opens down, so I'm going to label it up here so I don't interfere with the graph. We know it goes like that. Let's see, do we need a second point? Maybe, maybe not. Well, first of all, is it a minimum or a maximum?
It is a maximum.
And what is the maximum value? It says find the maximum value. What is the maximum value?
Um,
What's the y coordinate on that vertex?
8.
Describe the domain and range. Now, for parabolas, this is pretty common. In other words, it's pretty easy. The domain is always all real numbers for parabolas. Always. Anytime you have a quadratic, the domain is all real numbers.
Okay.
The reason is because I can substitute anything I want for x. There's no restrictions at all. I can substitute 0, -1/2, +1/2, +1,000,000, -1,000,000. That's what
Right.
domain is. Domain is all of the allowable values that you can substitute for x. And there are no restrictions. I'm not taking the square root of x, so it doesn't have to be a positive number. I'm not dividing by x, so it can be 0. But it's those kind of functions that have restrictions on domain. Now, range is a different story. Range is always going to be restricted for a parabola. Well, if I start from -infinity, which is where you always want to start your range from, if it goes to -infinity, and we can see that it does, that, in other words, if I extend those all the way down, they go to -infinity. Where's the top end of the range? In other words, what are the allowable y values?
So the negative.
Y value of 9?
No.
What's the maximum y value I can have?
8.
Do I need a parentheses or a bracket next to that?
Bracket.
Yeah, because it can be 8. We can see that it's 8 right there. So it's not that it approaches 8. It can be 8, but it's never greater than 8. And so that is interval. Are you familiar with interval notation?
Yeah.
That's interval notation for the range. And I'm sorry that they are both the infinity sign. One is on its side and one of it's straight up. But they shouldn't have used 8. But because there's no relationship between infinity and 8, just so you know. They just look the same. One is on the side. That's it.
Yeah.
Okay. So we've answered it's a maximum at 8, and the domain is all reals, and the range is negative infinity to 8 with a bracket. And now the last question is, where is the function increasing and where is it decreasing? In interval notation. Hold on a second. It's minus 1/8, right?
Yeah.
So in interval notation, where is it increasing? From where to where?
So from
And the answer is always the x-axis numbers, not the y. In other words,
okay.
you want to know what x coordinates it's increasing on.
So it's greater, or yeah. So from -1.
Negative infinity to -1. In other words, if I draw this in a different color, it's increasing that entire way, is it not?
Right. Yeah, it is.
So, and that bottom part is negative infinity. So all the way from negative infinity to -1, it's increasing. Now,
Right.
at -1, it's neither increasing nor decreasing. So I use a parenthesis.
Okay.
Now decreasing. What is the interval that it is decreasing on? Use the x coordinates.
So from -1 to infinity.
You got it. Now, the reason increasing and decreasing are important is because it's the beginning of calculus. When you get into calculus, increasing and decreasing are extremely important concepts. So they're kind of giving you an intro into it now. In other words, if I had a function that was like this, well, it's increasing from this point to that point, right?
Right.
It's also increasing from this point all the way out, but it's decreasing on that interval. So that would be increasing, but where it's going down, it's decreasing.
Right.
And like I said, when you get to calculus, that's an extremely important concept as to where a function is increasing and where it's decreasing.
Okay.
Well, that's probably a good place to stop, Demetrius.
Yeah.
What did we do? We just did 42.
Yeah.
Do you still have more problems on your assignment or not?
Yeah. There's 2 more.
Well, we're going to do exactly the same thing we've done on every single problem. We're going to start with the vertex of the x coordinate, which is equal to minus b over 2a. We're going to take that answer, fill it into the function to figure out the vertex of the y coordinate, and that'll be a major start on any problem, is to figure out where the vertex is.
Okay.
Okay?
Cool.
Demetrius, what is today? Tuesday, so I will talk to you again on Thursday.
Yep. All right.
Have a
Thank
good
you.
rest of your week. Bye-bye.
Thanks.